The box method is a good way to understand how algebra and addition can interact with each other, because again, multiplication and addition are two different things, but we can put them together and we can see how they can come together in this box method and how they interact with each other. So when we talk about multiplication in words, we were basically talking about length times width gives us the answer of area. So when we have 3 times a plus 4, well, we have a multiplication here, we have addition here. We can put them together by showing that 3 and a plus 4, this represents a factor, this whole thing represents a factor, or an entire side length, is going to be our length and width. So we see we have a length of 3, we have a length of a, and we add on 4. And we can see that the areas that we're going to generate are going to be, in this case, 3 times a. This area in here is going to be a length of 3 times a length of 4. That gives us 12. So we end up with 3a plus 12. And we often show this algebraically by showing that the length of 3 applies to both lengths of a and a length of 4, because that side of 3 is a shared side length. A shared side length means it's a common factor, so that is a common multiplier for both the a and the 4. We're also going to do prime factorings, and prime factoring is slightly different in that prime factoring, for factoring we have one length, one width. With prime factoring we have multiple multipliers, okay, so more than one. So it's hard sometimes when we get into more than 3 multipliers or more than 2, we need to have a different model, because this area model only has one length, a second width. So prime factoring is when we break up the multiplication and we don't have any addition, it's all multiplication. We break it up into the smallest parts, or the prime, what we call prime number parts. So if we have a number of 48, okay, we can break it up using a factor tree. And we can break up the multiplication. So 8 times 6 equals 48. 8 can be broken up further into 4 times 2. 4 can be broken up further into 2 times 2. 6 can be broken down into 3 times 2. And the ends of these trees represent the prime factor, the smallest multiplication pieces, and we put them all together. So we have 2 times 2 times 2 times 2 times 3 equals back to 48. We can do prime factoring in this kind of box method, where we can divide by, we start with 1050, and we can divide by 2, we get 525. We divide by 3, we get 175. Divide by 5, divide by 5, we end up with 7. So these represents our divisors, and which represents our factors. But these are prime factors. When we multiply them all back together, we're going to end up back with our original number of 1050. Okay, so we multiply that back together, we end up with 1050. So prime factoring are not factor pairs, but they are all the small, when we break up the multipliers into the smallest multiplication pieces, and we can combine them all back together with just times. Okay, so again, we make sure you understand that there's no plus involved when we talk about factoring. You can watch this video and that will give you an idea that talks about prime factoring in this video as well. So it's a good video to watch. So if we're going to start with 108, we can prime factorize this. So I start with 108. I'll do this both ways with the box in the tree. Okay. We can divide by 2 and we get 54 here. Here we can show that if we divide by 2, we get a factor pair of 2 times 54. So this is prime, this is prime. We can divide again by 2, so we can split up the 54 into 2 times 27. Okay, there's our prime piece here, there's the leftover prime. And then we can do this again with 27. Now 27 has a divisor of 3. And we're left with 9. There's another prime factor, and then we're left with 3 here. So these, when we break this down, we end up with 3's as our last. And we can express this multiplication now as in terms of the smallest multiplication pieces, and we can put them all back together by multiplying them all back together. And that will give us the original number that we started off with, which is 108.